Hello learners, from 3 previously we were dealing with the chapter 1. We are done with that chapter 1. Chapter 1 was chemistry of the gas law. So here today we are going to do chemistry of the mole as our topic 2. We are starting with lesson 1. So as you have seen the heading, the second chapter or the second topic is the chemistry of the mole. So what is a mole or what is mole? So mole is the amount of any substance that contains Avogadro's number of particles. If you are told define mole, we said a mole or mole is the amount of any substance that contains Avogadro's number of particles. So we are told Avogadro's number is a constant number and it is denoted by letter L, and it is given 6.023 times 10 power 23 particles or number of particles. So if we go back to the definition of the mole, we can also define mole as is the amount of any substance that contains 6.023 times 10 power 23 number of particles. That's how else you can define the term mole. Okay, we are going to go to see the particles include atoms, because remember we said in Form 2, atom is the smallest particle of an element. So we're having here electron. We said electron is negatively charged particle. Then we're having here ions. We said ion is a charged particle that's formed, so it's a particle. Then we're having here a molecule, and we said a molecule is the smallest particle of an element or a compound which can exist separately on its own. So all these that you have seen are just particles. Okay? Element is a pure substance which cannot split into simpler substance by a chemical means. Molar mass. What is a molar mass? Molar mass is the mass in grams of 1 mole of substance. If you're told what is molar mass, we said is the mass in grams of 1 mole of a substance. So let's go examples, because we are just dealing with the introduction side of the mole. But from this, we can have a formula, a small formula on the mole. That means if you are dealing with a mole, so 1 mole can have 1 mole can be equal to, check here, we are told a mole is the amount of any substance that contains Avogadro's number. So an Avogadro's number is given by 6.023 times 10 power 23 number of particles. So 1 mole will be equal to 6.023 times 10 power 23 number of particles. Okay, number of particles. So on the particles that we are talking about, they include atoms, they include electrons, ions, molecules, and so on and so forth. So this one will be the same again. It will be equal to, if you check molar mass, we said molar mass is the mass in grams of 1 mole. That means still again 1 mole will be equal to the molar mass. So we're having here molar mass. Okay, when you're talking about molar mass include relative atomic mass, which can be written as RAM, relative atomic mass. So that is the molar mass of an element. That's relative atomic mass. Or we can have RMM, that is relative molecular mass. If you are dealing with a molecule like water or like oxygen molecule, or like you are dealing with maybe nitrogen molecule or chlorine molecule, so you talk about the relative molecular mass as your molar mass. Then finally or lastly, we're having the RFM, which we mean by relative formula mass. Formula mass, you are dealing with a compound, like for example sodium carbonate. The molar mass will be the RFM. That means relative formula mass. So we are going to use relative formula mass when we are dealing with compounds like sodium carbonate, like we are dealing with the sodium hydrogen carbonate, like you are dealing maybe with potassium sulfates. That's when we are going to be dealing with the relative formula mass. So when you hear molar mass, all this come under molar mass. When you see ions, molecules, electrons, they are under particles. Now we have that 6.023 times 10 power 23 number of particles, and that will be equal to 1 mole. Okay, Let's go to the examples. We're having example 1. We are told copy and complete the table below. Okay, we are dealing with elements. So we're having hydrogen, we're having carbon, sulfur, iron, and calcium. All of these ones are elements that are in the first 20 elements in the periodic table. We are having only iron, which is a transition metal. So we know how to write hydrogen. The formula and the chemical symbol will be H alone. Carbon will be C, sulfur will be S, iron will be Fe, because the chemical symbol of iron derived from its Latin name, which was ferrum. Then we're having calcium there. The chemical symbol is Ca. Okay, thereafter, we are given the relative atomic mass of hydrogen. We are having we are told it's 1. Then that of carbon, we don't know. But remember, we said molar mass is just, when you talk about molar mass, you are dealing with maybe something to do with the relative atomic mass, relative molecular mass, or relative formula mass. So that means if I have molar mass, that means I have relative atomic mass. And if I have relative atomic mass, that means I have the molar mass. Okay, so if I'm having relative atomic mass of hydrogen as 1, that means the molar mass of hydrogen is also 1. Okay, then here I have the molar mass as 12 in the side of carbon, then the relative atomic mass of carbon is just 12, because we said molar mass is like when you're dealing with the relative atomic mass, relative molecular mass, and relative formula mass. They are just molar mass. Okay, when you're having relative atomic mass as 32, that means the molar mass will be also 32. When you're dealing iron and you know it is molecular mass or molar mass, sorry, it is molar mass, it's not molecular, the same will be the relative atomic mass. So here we don't have calcium on both sides, but the relative atomic mass of calcium is 40. That means the molar mass of calcium will be also 40. So let's come to see the number of particles. These are now elements. That mean molecular mass, we said, is equal to the number of particles, as we have seen from the formula here. We said 1 mole is equal to the Avogadro's number of particles, which is given by 6.023 times 10 power 23 number of particles. It will be equal to the molar mass of the elements. So here, the number of particles will be just 6.023 times 10 power 23 number of particles when you are dealing with the molecular mass of hydrogen, which is 1. So that means when you're dealing with carbon, which is element, and the molar mass of carbon is 12, that means the number of particles will be 6.023 times 10 power 23 number of particles, because this number of particles is a constant. Okay, then that means if you are dealing with iron and the molar mass of iron is 56, it is just equal to the number of particles, which is given by 6.023 times 10 power 23 number of particles. So that means we are done with that question. That's question number 1. So we are going to go to question number 2, and we are told how many atoms are there in 1 mole of oxygen atoms. So remember, we are told here 1 mole. The formula, 1 mole will be equal to 6.023 times 10 power 23 number of particles. But examples of particles include atoms. So when you are told how many atoms are there in 1 mole of oxygen atom, we are going to say just 1 mole. 1 mole of oxygen atoms contains 6.023 times 10 power 23 number of particles. But the particle that we are talking about in our case here will be atoms. So the answer will be 6.023 times 10 power 23 number of atoms, or atoms. So number 3, we are told how many atoms are there in 40 grams of calcium. So here in this case, the relationship that we are going to be dealing with is atoms with that of calcium, which we are given now the molar mass. Remember, whatsoever you are given in bracket will be the molar mass. So check the relationship here. We are told 6.023 times 10 power 23 number of particles, which includes atom, because here they are asking us atoms, will be equal to the molar mass. And the molar mass of calcium is given in bracket, which is 40. So to relate, we are going to say 6.023 times 10 power 23 atoms will be just equal to 40 grams of calcium. So what about 20 grams of calcium? how many atoms is it going to give us? So we cross multiply. So there we are going to get 6.023 times 10 power 23 times 20 over 40. So here, what I'm going to get will be 3.0115 times 10 power 23 number of atoms. So that will be my answer. So in this example 3, we are relating number of atoms, that's the number of particles, with the molecular mass, with the molar mass, molar mass. Okay, next we are going to go, we are told calculate the mass of the following atoms, the mass of the following atoms. So here, we don't have mass, and where are we going to get mass? We are going to get mass from the molar mass. Okay, so if we are dealing with aluminum, aluminum is a metal, so it's an element. That means I'm going to get from the relative atomic mass. Okay, so calculate the mass of the following atoms. I'm given 3.0115 times 10 power 23 atoms of aluminum. So the relationship will be 6.023 times 10 power 23 number of particles will be equal to the molar mass of aluminum. So we are going to write that here, 6.023 times 10 power 23 number of atoms will be equal to 27 grams of aluminum. So for us to get the mass of aluminum, that means they have given us the number of atoms. That means 3.0115 times 10 power 23 atoms will be equal to what? So we are going to cross multiply. So here we are going to have 3.0115 times 10 power 23 times 27 divided by 6.023 times 10 power 23. Yeah, so here we are going to get 13.5 gram as our mass. We're having 13.5 gram as our mass. So thereafter, we are going to go to question number 5. Then we are told calculate the following. So we are told, before that, let's go to Romeo B. So here we're having 12.046 times 10 power 23 atoms of iron. So the formula will be the same again. We say 6.023 times 10 power 23 atoms of iron will be having the molar mass of 56 grams. So we are going to say, what about 12.046 times 10 power 23 atoms given? What mass of iron does it get? So we are going to cross multiply 12.046 times 10 power 23 times 56 divided by 6.023 times 10 power 23. Here we are going to get 112 grams of iron. Okay, number 5, we are told calculate the following. We are told number of atoms in 0.6 gram of calcium. So here what we are relating is number of atoms with moles. So what have we said about that in the formula? The formula we were having here, 1 mole is equal to 6.023 times 10 power 23 number of particles, which include atoms. So here we are told number of atoms. So we're saying 1 mole is equal to 6.023 times 10 power 23 atoms. So I say, what about 0.3 mole? What about 0.3 moles? So cross multiply. I'm going to get 0.6 times 6.023 times 10 power 23 divided by 1. So here I'm going to get 3.6 times 10 power 23 number of atoms. That's what I'm going to get. So next we are told again the number of atoms in 11 grams of potassium. So the relationship here is we are told number of atom, and here we have molar mass. So the relationship will be number of atom, which is 6.023 times 10 power 23 number of atoms will be equal to the molar mass, which is 39 grams. So if they have given us now 11.7 grams of potassium, what will be the number of atoms there? So we are going to cross multiply. We are going to say 6.023 times 10 power 23 times 11.7 divided by 39. So here, what are we going to get? We are going to get 1.8069 times 10 power 23 number of atoms again. That's what we are going to get as our answer. Then lastly, we are told mass of 1.2046 times 10 power 23 atoms of sulfur or sulfur atoms. So the relationship will be again still number of particles, that's Avogadro's number of particles with that molar mass. So we are going to say 6.023 times 10 power 23 atoms of sulfur will be equal to the molar mass of sulfur, which is 32 grams. So if they're asking the mass, that means I don't have here, they have given me the number of sulfur atoms, which is 1.2046 times 10 power 23 atoms of sulfur. So let's just cross multiply. We are going to say 1.2046 times 10 power 23 atoms times 32 divided by 6.023 times 10 power 23. So here when you put it in the calculator, you are going to get 6.4 grams of sulfur. That will be the mass of sulfur. Okay, that's the end of our lesson. Thank you.